In my last video about rocket fuel, I made a new sugar fuel type that doesn't need to be heated for grain casting. That fuel could be cold casted using water or alcohol, and potassium chlorate was used as an oxidizer. I thought that I have made a perfect fuel because the test burn was very stable and didn't show any uncontrolled burn. With that achievement, I decided to make a rocket motor with this new fuel. In this video, I will show you how I made and found components for a PVC rocket motor, how I used random stuff for motor fabrication, and why using potassium chlorate always ended up putting me into trouble. I started by mixing and measuring ingredients as always: potassium chlorate, sugar, dextrin, and cement powder. I ground the sugar and chlorate into a fine powder. During the entire process, I took care of safety, because safety comes first. All the flammable stuff was kept far from the mixing table, and I wore a mask and safety glasses. You should not try this. If you do, keep safety as the top priority. I mixed everything and ended up with a gray powder. I really didn't notice during making, but during editing, I found out that I only made 150 grams of fuel. At that point, I completely forgot that this fuel is not like charcoal fuel. Sugar compresses more, which means 150 grams wouldn't be enough. In my last video, I made a 50-gram batch for a single sugar grain, and that was not enough. But when I was using charcoal fuel, 50 gram was too much for a single 2.33-inch grain. Next day, I started working on grains formation. The motor design was similar to my previous motor design, but only the nozzle would be different. For casting grains, I was using some metal washers with 0.5-inch inner diameter, 3 PVC 2.33-inch pipe, hand sanitizer, thick chart paper, and a lipstick tube. At first, I slowly added sanitizer to fuel and mixed it until it turned into clay. The only thing I don't like about this fuel is its smell. It smells very weird when I add sanitizer into it. After that, I added chart paper into PVC and started casting. The sugar fuel was a little too sticky, and it was sticking to my fingers. To solve this problem, I added some white stuff to ramrod and to finger because it would make it non-sticky. I slowly packed clay fuel inside PVC pipe and pressed it with my fingers and wooden ramrod. When the PVC pipe was fully filled with clay fuel, I made a core in the grain using metal washers and lipstick tube. If you ask why I was using lipstick as a coring rod, I didn't have anything that fit in that washer perfectly. But that lipstick fits perfectly, and this is called real DIY. One by one, I made 2.5 grains. Why 2.5? Because the 150-gram fuel was not enough, and the last grain only filled half. I covered that half grain with cotton and quickly made a new 40-gram batch for it and filled that half grain. After that, I ended up with a little leftover fuel and made a ball of that, and it will be tested later. All the grains were looking good, so I left them to dry, and it wouldn't take much time because of the sanitizer. After that, I started working on the nozzle. In my last motor build, the nozzle was very simple and had a throat diameter of 0.5 inches. For this new sugar motor, the throat diameter would be 10 millimeters, and that's because the maths equations for finding nozzle throat diameter explain that 8 to 9 millimeter diameter would be perfect for my motor design. But I didn't find any 9 millimeter diameter washer, so I chose to use 10 millimeter because it was available at that time. At first, I added a large washer inside the PVC coupler. This is because the washer with 10 millimeter diameter wouldn't fit inside, so it would sit on top of the large washer. The large washer fit perfectly. To secure it in place and to make a good base for the motor tube, I cut a ring from PVC and glued it inside the coupler on top of the large washer. After that, I glued the small washer at the back of the large washer using super glue. There was a gap between the wall of the coupler and the small washer. I filled that gap using adhesive clay, and it became nice and hard. I also added a piece of PVC pipe at the end. It's not an important step, but it improves the performance of the nozzle by reducing the chance of flow separation problems. If you want to know about flow separation, you should see some videos about it. There are a bunch of videos on the internet. I cut the extra part and made it smooth using sandpaper. After assembling everything, I made a batch of clay and cement powder mix, and using my fingers, I made both the converging and diverging sections of the nozzle. I tried to make the diverging section with a metal pipe, but that clay mix was sticking to it, so I made it by finger, though it was a little hard to shape with fingers. The nozzle was looking perfect, as you can see in these video clips. The next day, when I was preparing for motor assembly, I noticed that the clay nozzle had lots of cracks in it, and the converging section was separated from the nozzle. It all happened because the clay shrank too much during drying. I tried to fix that by applying some cement on top, but it didn't work as I thought, and when I tapped the nozzle on the table, the diverging section completely separated from the nozzle. Same with the converging section. I removed all the clay and started making both sections again. This time I first made the sections with clay adhesive, and it was sticky, so I used Coke again. It really helped. When both sections were done, I added a layer of cement on top because clay adhesive can't handle the heat inside a rocket motor. That new nozzle was perfect because it didn't have any cracks at all. The next day, everything was fully dry, and I started assembling the motor. I measured the weight of all components, and then to make the end cap stronger, I added some clay adhesive inside. In my last attempt at motor building, I glued all the grains together, and I was trying to do the same for these grains, so I glued them and taped them. That looked promising, but it didn't work. The glue made the grains wet and they didn't stick together. When I tried to put the grains in the motor tube with chart paper, they just didn't fit. I tried so hard and even tried to put them separately, but it was not possible to fit them inside with chart paper. Then, I accidentally broke one of the grains. After burning the pieces of the broken grain, I immediately made a new grain, and the day was over by that. Next day, I somehow put all the grains in the body tube. Don't ask how I did it. The only thing that matters is that everything is assembled. After that, I attached the nozzle and end cap using PVC cement. Then, it was time to test something new. Instead of leaving the motor body as it was, I decided to reinforce it using adhesive and some strong string. I wanted to use epoxy for that job, and I had some at that point, but it was 5-minute epoxy, and it would dry too quickly. That's why I used regular adhesive. I applied 2 layers of string and layers of glue. That process took over an hour, but in the end it was all fine. The next day, the motor was fully dry and ready to be tested. I made an igniter and set up the motor with some bricks. Once again, I want to warn you guys that all of this was under control and done following all safety rules. Do not try this yourself anywhere. After setting up my phone, everything was clear for the test. I prayed and lit the motor. And it exploded again. That sugar fuel was very stable and was burning slowly during testing, but it somehow exploded. I'm sorry, but I can't show this explosion because it was too huge. All 5 bricks around the motor were broken into small pieces. I think everything was good except potassium chlorate, because if we look closely, we notice the motor exploded just after lighting up. Unlike a normal motor failure, where the motor doesn't explode immediately and fuel pieces can be found around the test site. During cleaning of the test site, I didn't find anything like that, which means all the fuel exploded, and it was because of potassium chlorate. It explodes whenever it gets under pressure, as we can see here. My motor design is good, but I need to use nitrate now. That's the only option left. If you came this far, thank you so much for your time. If any of you have questions, feel free to comment below or contact me on Instagram. I'll see you in the next video.